In this next lesson, we're going to be discussing inequalities rather than equations. Inequalities are pretty similar to equations. It's just that rather than having an equal sign between two expressions, we're going to have a less than, greater than, less than or equal to, or greater than or equal to sign in between them. So instead of having 2 plus x equals 5, we're getting rid of that equal sign, and we now have maybe a greater than sign, for example. Recall that a solution to an equation was any value that you could plug into the variable and make the statement true. That is still true for inequalities. A value is a solution if when you plug it in for the variable you get a true statement. So in the 2 plus x is greater than 5, for example, if I did 2 plus 6, that would mean that 6 is a solution because that makes a true statement. 7, or actually that'd be 8. 8 is bigger than 5. It's greater than 5. Now, what makes inequalities a little bit different is that rather than having an option of having only one answer, or maybe even no answers, or an infinite number of answers, these are often going to have an infinite number of answers. They're going to have a whole range of values. There's lots of numbers I could plug in for x in 2 plus x that would give me an answer bigger than 5. So what I do to show that is I plot something on a number line. Like maybe if I had something like this, I would shade all the values that make the inequality true. So I might have something that looks like this. Now, when we're talking about these dots being an open dot or a solid dot, that first picture that I've drawn, that's a solid dot. It shows that the 2 is part of the solution. Whereas if I were to draw it like this, it would mean that 2 is not part of the solution. But any number a tiny bit bigger than 2, so maybe then 2.000001, that would be a solution. Let's try a few examples. First we have all real numbers less than 2. So we're going to write that as x is less than 2. For my graph, I'm going to put a 2 in the center of the number line. I'm going to include one number larger and one number smaller than 2. Remember that we said a strictly less than sign is going to be an open circle when I go to do the graph, because 2 is less than 2 is not a true statement. So it's not colored in, it's not part of the solution. That's a false statement. 3 is less than 2, that's also false. So I'm not going to be shading in the side of the number line that has the 3 on it. But 1 is less than 2, that's a true statement. In fact, all of these numbers to the left of that boundary point, the 2, they're all going to be solutions. So for example, 1.5, 1.2, 0.3, negative infinity, anything else that I could plug in there would work and make a true statement. Next we have all real numbers greater than negative 2. So that's x is greater than negative 2. Pretty similar, I put the negative 2 in the center of my number line. I include one number larger and one number smaller on the number line. Still a strictly greater than sign, not equal to, so I have an open circle. And then I do a test point on each side. I want to see, is negative 3 greater than negative 2? It's not, so I don't shade that side of the number line. Is negative 1 greater than negative 2? It is, so I shade that side of my number line. Next we have all real numbers less than or equal to 1. So x is less than or equal to 1. Again, that boundary number, that 1 is what goes in the middle of my number line. I include one number larger than that on the right and one number smaller on the left. This time there is an equal to sign as part of my inequality. So I color in this boundary point, and that's because this is true. If I plug in a 1 for x, 1 is less than or equal to 1, that's a true statement. If I were to plug in the 2, 2 is less than or equal to 1, that's false, so I'm not going to shade the side with the 2. And if I plug in a 0, 0 is less than or equal to 1. That's a true statement. So I will shade on the side of the number line that has the 0. One last one. All real numbers greater than or equal to 0. So 0 is my boundary number in the center. One number larger, one number smaller. An equal to is part of it, which means 0 is actually a solution. 0 is greater than or equal to 0. That's true. And then I try my test points. -1 is greater than or equal to 0. That's false, so I don't shade on the left of the number line. 1 is greater than or equal to 0. That's true, so I do shade on that side.